5, we're taking a look at number 4. Is 3, 1 a solution to my system? What's my x coordinate here? 3. What's my y? 1. I'm going to take my first equation first. I'm going to plug in 3 for x. I'm going to plug in 1 for y. Solve it out. What's negative 2 times 3? That would be negative 2 plus 3. Very close. If we're multiplying 2 times 3, that would be if we're adding 2 plus 3. Negative 2 times 3 is negative 6. What's 3 times 1? 3. Bring down the minus. And now we subtract. What's negative 6 minus 3 more? Negative 9. That's right. Is negative 9 equal to negative 9? Sure is. My first equation is true. Let's see if it's true for the second equation, though. 4 times 3 minus 3 times 1 equals 9. What would 4 times 3 give me? 12. Bring down the minus. 3 times 1 is 3. What's 12 minus 3? 9. Is 9 equal to 9? Yes, it is. That is another true. So what's my answer here?
All true.
Right, they're both true, so what's my answer?
Yes, 3, 1 is.
There we go. Yes, 3, 1 is, good morning, thank you, is a solution. The question is 3, 1 a solution? So if that's the question, my answer is going to be yes, 3, 1 is a solution. Right? The true is just us checking the equation. That's not technically the answer. Right? My answer would be yes, 3, 1 is a solution. All right? If we drop down to 5, is 0, 0 a solution to the system? Some of you guys were able to do this completely in your head because we know what happens when we multiply anything by 0. We get 0. 7 times 0 minus 4 times 0. Well, that's going to be 0 minus 0. Is that equal to 0? Yes. Let's take the second equation. I have a feeling we're going to get a similar result. Negative 3 times 0 plus 8 times 0 equals 0. Is 0 plus 0 equal to 0? Yes, it is. What's my answer here? Yes. There we go. 0, 0 is a solution. That one's not too bad. I know you may have had some second thoughts because it was a little too easy almost, but nope, you're right. That is a solution. Scatter plots on the back, starting off with my association, right? There's 3 different types, positive, negative, and none. What type of association do we see in number 7 here? Negative. My line's going downhill from left to right. That's as negative of an association as it gets. What do we see in number 8? I see no association at all. These points are just scattered about. Right? There's no clear kind of makeshift line going on here. They're kind of just all scattered everywhere. It's kind of like a ghost. And what about number 9? What's my association there? Positive. We're clearly going uphill from left to right. Right? Even though it's not a perfectly straight line, all of my points are tightly bound up in that kind of direction. What about number 10? There's a lot of points there. What's my association? Negative association. If we just kind of like group up all the points, that is clearly a downhill sloping line just like we saw in number 7. The points aren't as tightly wrapped up and bound together, but they're all still going in the same direction, which would be down. As the x increases, the y decreases, That is a negatively associated group of data. All right? Any questions about those? Cool. Pretty straightforward. Pattern recognition, right? Number 11, just so we're all clear, I know there was some questions on this. All you're doing is identifying the coordinates of these points. So this first person had 1 absence, and they had 11 missing assignments. What would we call this point up here? The outlier. So 11B at the bottom, my outlier is at 111, right? It does not fit in with the rest of this data. It's outside of the association. Someone that had 2 absences only had 3 missing assignments. That's that point right there. But we noticed 2 people had 3 absences, right? One of those people had 4 missing assignments, and the other person had 5 missing assignments. So those are 2 separate points, just lined up on the same x coordinate. All right. The next one, someone with 4 absences had 5 missing assignments. And something that we're going to talk about today, if we look at this, right? I've got an input of 3 with an output of 4, and an input of 3 with an output of 5. So does this represent a function? Well, if we put in a 3 and get out a 4, can we then put in a 3 and get out a 5? No, right? That's what we're going to review today as functions, right? If we have same inputs, we cannot have different outputs. I know that's not part of this question, but just to connect our little ideas here, this is obviously not a function, right? We see those 2 points directly in line with each other vertically here. Not a function. Again, that's not part of this. That's just going to be what we talk about today. You can figure out the rest of the points. Are there any other questions we could answer? That one wasn't too bad, especially compared to F04. We all good? Cool. Go ahead and pass F05.